Okay, the forces that are acting on the system. I'll continue the problem here. So this is the rough surface. First we'll get the things. What are the various forces that will be acting on the wedge block? So first what happen? The free body diagram. From there we'll proceed here. The surface is smooth. Let's keep it. mg sine theta, normal reaction, mg cos theta. Strict condition, what is given? The wedge should not move. So therefore, what shall I write here? This should be a test. This is a basic condition. No? The wedge should not move. That was the question given. Shall I show any friction between the block and the wedge? No. There should not be any friction. So this is a normal contact. And I'll give color like this. This is the normal contact. Then the weight of this will act. The weight of the wedge will act. 2 mg. There'll be normal reaction by the ground on the wedge. It will be in this direction. What possible direction the friction should act on the wedge by the ground on the wedge should be because of n1 sine theta it will try to shift. So the friction by the ground on the wedge should be in this direction. By the wedge on the ground should be towards right. Let it be this one. So here you can look at this n1. So this n1 sine theta what happened will try to shift the wedge towards right. And since the wedge is kept on the surface, no, so the ground what happened will exert a frictional force on the wedge towards left, and under action of n1 sine theta and the friction, the wedge is at rest here. So if you resolve this force, if you resolve this n1 sine theta, this will be n1 cos theta. Try to look at this one. So first we'll get the n2 now. So forces acting. First, what is n1? What is the state of block? Block what happened? Block this block can slide. We are not bothered, but still this will have acceleration. Let's not bother because this is smooth, no? Because of m1g sin theta, it will slide down. But still, n1 is equal to, or say like n is equal to n1 equal to mg cos theta. Because what is the net force on the block perpendicular to incline? Should be 0. So what is n1? N1 should be equal to m1g cos theta or mg cos theta. This is the one equation. Let's have that one. Now, here what is n2? Looking at this on the wedge, n2 minus 2 mg, n2 minus 2 mg minus n1 cos theta equal to 0. Let me substitute theta value. What is theta? Theta 45 degrees. So n1 equal to mg by root 2. So n2 minus 2 mg. n1 is mg by root 2. Cos theta, this will be 1 by root 2. n2 is equal to 3 mg by 2. Then for the wedge not to shift, I'll write it here. For wedge not to shift. What is the condition you can write? n1 sine theta minus f should be equal to 0. So what is n1? mg by?
It should be 5 mg by.
This is 5 will come. Okay, now n1 will be mg by root 2. sine theta 1 by root 2. The friction force will be mu N2. So this will be mg by 2 minus mu. What is value of N2? 5 mg by 2. So mu equal to how much? 1 by 3, I'll get it.
Sir, 1 by 5.
1 by 5, sorry. So this should be your answer. So slowly try to focus on the problems. If the friction is there between the wedge and the ground, if there is a friction is there between the block and the wedge, take this one. In Pathfinder, questions are there. Today you can work out based on the questions. There's 1, 2, 3 problems are there where there's a friction between block and wedge. Try it. On Friday, I'll discuss questions from Pathfinder. Friday, Saturday, we'll discuss questions which are related to Pathfinder. Very good ideas are there, but you need time. Not like by seeing you'll get answer. Two mg is there, N2 2 mg. That's all. No, why mg of the block will not come into picture. No, only the forces acting on the wedge what happen will determine the N2. Completed this. There can be questions between the PDF. I do send no. Assignment I'll give today because almost the most concepts you will be coming across. Today I'll give assignment. You can work out. Okay, now fine. I will go for the next condition.